Hi friends, today we are going to learn a battery charging sections of laptops. In laptop motherboard there are two power input. One is my adapter and another is the battery, and this is the one output. These are the two inputs, one is here and one is here, and this sections control this two power, okay, and simultaneously it's a provide a charging voltage also. So now here are 5 MOSFET. These are the 5 MOSFETs are here. The MOSFET pin number 1, 2, 3 the source. Here's the pin number 1. Pin number 1, 2, 3 the source. Pin number 4 is a gate, and 5, 6, 7 is the drain. Okay, and this chips manage all this MOSFETs. The control their gets managed by this chip. This chip is called the battery charging chips. And when we connect the adapters here, suppose my adapter voltage is 18 voltage. My 18 voltage, this voltage stop here because this gate is not triggered as yet. Okay, and this all are N channel MOSFET, and this MOSFET is a P channel MOSFET, and this AD plus written over here, that means AD plus means AD plus. This connection is connected to this gate, and okay, so when I connect the adapter here, my voltage is stopped because this gate is not, this gate is controlled by these chips. And now the next is this. Now this chips require a power to work. This battery charging chips require a power to work, and here get a power from here. You get a 18 volt power. This is called the DC in, or sometimes called a VCC. These chips normally 24 pin chips or 20 pin chips depend on the manufacturers, and when you get the power is ready to work, then you get the next signal is called the AC in. AC stand for adapter current in. We get the adapter current in. When the adapter voltage is connected here, that is 18 volt, and here are two resistor voltage divider resistors are here. According to the Ohm's law, here will be the voltage develop, the voltage drop will develop, and this voltage goes to these chips. These chips have a different pins, and the different pins have a different works, different role. This one pin is called the AC in pin, AC detect or adapter current detect. That voltage is supposed to be a 2.4 voltage or something. Okay, so once you receive this AC detect voltage at this pin, then this chips drive AC drive voltage and is trigger this two MOSFETs. Okay, see like this is trigger this two MOSFET. Once it trigger this two MOSFET, my voltage which stop here, which cross all this two MOSFET from this line and goes out, this output, this goes inside the laptop. So once I trigger this voltage, my voltage will travel from here to here. Okay, so this voltage will travel from here. So here is a small resistor. This resistor's value is 0.02 ohm resistor. This is a current sensing resistor. So here will be voltage drop, and this voltage drop count by this resistor. So he will assume that he's taken the voltage inside. So in like that, and after that this battery charging chips communicate with the SIO. He generate one signal that is called AC OK. That means adapter current is OK. He generate there 3 volt. He generate there a 3 volt. Here will be a 3 volt. If this 3 volt is coming here, that means the power is working, laptop is working on adapter, and if it is a 0 volt means adapter voltage is not is detected. And the next is there are two wire communication protocol. It's called a SM bus. SM bus stand for the system management bus. Is a two wire communication protocol between the chips to chips. Here this battery charging chips communicate with the SIO. This is called the SIO, super input output controller, and simultaneously communicate with the battery also. This is a bidirectional communications, a two-wire communication protocol is to communicate with the SIO and simultaneously the battery. Now the next is he communicate with the battery and check whether the battery need a current. Okay, and if the battery need the current, he develop the current at this battery terminal. Battery have a 5-6 terminal, like one is a positive, one is a negative, and two are the assemblers, and one for the battery present and another for the battery temperature. So like that. So once battery asks current from this SIO give the command to this battery charging chips, and battery charging chips started triggering this MOSFET number 3 and MOSFET number 4. He get the voltage 18 volt from here and started generate pulsating AC here, pass the DC, gather across the capacitor and pass into the battery like this. You can see these pulses are generated here, started chopping this MOSFET, both are the N channel MOSFET, started triggering. He taking a 18 voltage and generate a required voltage to the battery, required voltage and current to the battery. Battery normally is supposed to a 10.8 volt, depend on the model to model, it's a variable, but we'll see, we'll take approximately a 10.8 volt, and this 10.8 volt goes to the battery and battery started charging. Okay, so in this work, now we'll assume that what happen if we remove the battery, if we remove the adapter. Okay, we'll see. Now here is a 18 volt. When I connect the adapter is 18 volt, and this 18 volt goes like this, and this 18 volt AD plus is connected here also. This is a P channel MOSFET. Okay, this is a P channel MOSFET. And what is the function of the P channel MOSFET is that when we give a positive voltage to the gate, at that time the MOSFET get disconnected from source to drain. It's get a disconnected, it's not a connected. And when we apply a negative current to the gate, it get connected, where the N channel MOSFET work reverse. For N channel MOSFET conducting, he require a positive current to his gate, but in the P channel MOSFET he require a negative current to the gate to trigger. So now here, suppose here is a 18 voltage and this 18 voltage path is connected to here also. That means that time this MOSFET is disconnected, it's an open street. And when I remove this adapter, here I will get a 0 volt, and same 0 volt is here also. At that time when here is a 0 volt, if I remove the like this adapter, at that time here is 0 volt, at that time here also the 0 volt, and then this 10.8 will travel from here to here to here. It's like that. So in this way, when we remove the adapter, this MOSFET work like this. So we'll see in this concept of battery charging section how the section work. Now if you understand this concept, then you can repair 3 to 4 you can diagnose to 3 to 4 types of problem in any laptop. The problem number 1, if you have a laptop and which is not powering on with the adapter, suppose you connect the adapter and laptop is not working on the adapter, but laptop working on the battery as soon as the battery charge. So that means the possibility is that maybe these two MOSFETs are open. Number 1 possibility. Number 2 possibility, maybe this resistor number 1 is open, or maybe this chip is a faulty, it's not giving triggering to this MOSFET. These are the possibility if the laptop is not working on the adapter but it's working on the battery. So this problem number 1. The problem number 2, if you have a laptop which is not working on the battery but it's working on the adapter. If when I connect the adapter, it's working fine, it's showing the battery 100% charge, but when I remove this adapter, the laptop is turned off. Then there is a possibility is that this MOSFET number 5 is open. you have to replace this MOSFET. So this is problem number 2. Then problem number 3, the battery is not charging. This is a very common problem in any laptop. So what is the responsible for the battery charging? The battery charging responsible, first is this 18 voltage, and then this AC/DC in, and then this AC in detect signal. When he receive this AC detect signal, he generate the ACOK signal. ACOK signal supposed to be a 3 volt. Supposed to be a 3 volt. You should get a 3 volt at ACOK pin. Now this ACOK pin is not getting a 3 volt, but he is receiving at least 2.4 volt at AC detect or AC in pin. Then the possibility fault in the battery charging chip. If it is not getting a 2.4 volt, then possibility these resistors are open. If it's getting more than 2.4 volt but not getting a ACOK signal, then possibility is chip. If it's receiving the ACOK signal but still is not charging the battery, then possibility maybe the chip, you have to replace the chip, or you have to check this MOSFET and check this capacitor, like that. You have to check, you have to concentrate only on this section. But before doing anything, you have to try to change the battery first. You have to put a battery and check. So in this way you can solve a battery charging problem. The next problem is sometimes the battery is not detected. Battery is not detected. At that time you have to check the communication. At battery terminal there are 5 to 6 terminal. In that there are 2 wire in between, these called the SM bus. At that SM bus there must be a 3 volt, and there must be show some pulses on the oscilloscope. If these pulses are coming, that means the battery is communicating with the SIO. Or if not happen there, then possibility could be battery is faulty or SIO is faulty, or sometime EC bias is corrupt. So we see in this way how to solve the battery charging, how to solve the battery related problem and charging section. Thank you very much for watching this video.